You better note down this algorithm from now on. So congestion control algorithm has 3 steps. Congestion control algorithm at TCP has 3 steps. First step is slow start, or 3 phases we can say. First phase is slow start phase. In this phase, it starts with 1 MSS and gradually grow until the threshold. And the second phase is congestion avoidance phase. So congestion avoidance means congestion has not yet reached, it will be careful so as to not hit the congestion. And third phase is congestion detection phase. So during either the first phase, slow start phase, or congestion avoidance phase, it can detect the congestion, right? So during this detection, once it detects the congestion, then it is going to react to this. Now how can we detect the congestion? So there are 2 ways in which we can detect the congestion, actually 3, but for this algorithm let's take 2. So one way to detect the congestion is whenever a packet is lost, which means a segment is lost which you have transmitted, and after that all the segments are lost. That is one way to detect the congestion. So that is called as timeout. So timeout is going to detect the congestion. And second one is one segment is lost, and after that segment 3 segments have been sent and acknowledged. That is called 3 duplicate acknowledgements. 3 duplicate acknowledgements. Okay. So just observe this. Slow start phase is initial phase, and then we enter into congestion avoidance. And during slow start phase or congestion avoidance phase, even though I am writing it as third phase, it can occur anyway, right? So we are going to detect the congestion. How do we detect a congestion? Whenever a packet is lost, whenever a segment is lost, either we get a timeout or we get 3 duplicate acknowledgements. And timeout indicates that congestion is severe. There is severe congestion or congestion has already occurred, and this one indicates that the congestion is mild. Mild means it is not so severe, so you need not react so severely, right? And any of these 3 phases, all these 3 phases are going to be there in the congestion avoidance algorithm. So I will take an example and explain you. And there is one more way how we could detect the congestion, so that is ICMP. In ICMP we are going to use that ICMP source quench. So ICMP source quench is some people use it as the congestion indicator, but then it doesn't talk about the entire network. It talks about only one particular host. When one particular host is very busy, then it is going to send source quench. So sometimes this ICMP source quench, there is actually ambiguity whether to take it into consideration or not. So most of the algorithms doesn't take it into consideration. So I'm not going to take it into consideration in this algorithm. So even though this is one of the ways we could detect the congestion, I'm not going to consider it because most of the implementations are not considering it. So I'll explain you each phase by taking an example, okay? And then we shall discuss what happens in each phase. Let us assume that the receiver window advertised is 64 KB and MSS is 1 KB. Then what is the maximum receiver size? Maximum receiver size is 64 MSS, right? Then what is the threshold? Threshold is 32 MSS. 64 by 2 is 32 MSS, right? Then how does this algorithm work is, so initially we start in slow start phase, and we gradually grow 1, 2, 8, 16, 32. So till this part it is called slow start phase. So maybe you could write down a point there. Slow start means here I start with 1 MSS and I gradually grow exponentially till I reach the threshold. So slow start phase starts with 1 MSS. Some of the implementations they might even start it with 2 MSS. So keep that in mind. Some slow start phases start in 1 MSS and some people will start with 2. Either 1 or 2, it doesn't matter much. So let us say it starts with 1 MSS and grows till the threshold in exponential manner. That is the first point. And now congestion avoidance phase. Congestion avoidance phase is, it starts after you reach the threshold. So you are going to start with 33 and then 34 and then 35, so on 64. So this entire phase is congestion avoidance phase. So what does congestion avoidance phase do? It starts after the threshold, and then till you reach the maximum receiver window size, we are going to grow linearly. So after that, we are going to stay there. There is no point in going or sending beyond 64 MSS, because receiver can hold only 64 MSS at any size, at any time. Therefore, there is no point in sending more than 64 packets when the receiver is clearly saying that my capacity is 64, right? So if you look at the graph, it looks like this. We start with 1 MSS and grow exponentially till we reach the threshold. And once we reach the threshold, we grow linearly till we reach the maximum receiver capacity. And after reaching there, we are going to stay there, right? So in this previous example, I am going to start with 1, and till 32 I am going to grow exponentially, and after 32 till 64 I am going to grow linearly, right? That is how congestion algorithm worked here. Then what about the congestion detection? During any of these phases, congestion can be detected and we are going to handle it. So let's see how congestion is detected and how we are going to react to each of these cases. I'll take the same running example and I'll explain you how the congestion is detected and what are we going to do. So assume that the same thing. I'll just assume the same example and show you what happens with this. So assume that the maximum sender window size advertised is receiver capacity advertised is 64 KB, and maximum segment size decided is 1 KB. Then what is the receiver window size in terms of MSS? 64 MSS, which means at any time you can send 64 MSS without looking for the acknowledgement, without waiting for the acknowledgement, right? And now if this is the case, then what is the threshold? Threshold is 32 MSS, right? Then how does the congestion window grow? So how are we going to send the packets? We are going to start with 1, and then 2, and then 4, and then 8, 16, 32, and after that 33, and then 34. Let us say our algorithm has reached this point, which means I have sent 34 MSS, 34 segments, and then I am just waiting now. So how can the congestion be detected? Two ways, either by timeout or by 3 duplicate acknowledgements. Let us say after sending 34 packets, one segment is lost, and after that all the segments are lost. Therefore I got a timeout. So whenever you get a timeout, then what happens is this is held like this. New threshold is equal to half of the current congestion window size, which means at this point the new threshold will be half of whatever your current window size is, which is 17. So new threshold is like that, and then algorithm enters slow start phase. So why will we again start slowly is timeout is a severe congestion condition. Therefore new threshold is half of the current window size, and again we start slowly from slow start, which means again you have to start from 1 MSS, 2 MSS, 4 MSS, 8 MSS, 16, but then we cannot go till 32 because new threshold is 17. Therefore 17 we go there and we stop there, and again next thing is we continue with 18, 19. Let us say at 20 there is 3 duplicate acknowledgements, which means we have sent 20 segments. After sending 20 segments, one segment is lost, some segment in the middle is lost, and after that 3 segments have been received. Therefore we get 3 duplicate acknowledgements. In this case, if I get 3 duplicate acknowledgements, then it indicates that congestion is mild. Then also in this case what happens is new threshold will be made half of the current congestion window. So what is the current congestion window now? 20 MSS. It will be made half, which means new threshold will be 10 MSS. Okay, but then the algorithm enters not the slow start phase, it enters congestion avoidance phase. So congestion avoidance phase means we start from new threshold, which is 10. We start from 10 and we grow linearly because it is congestion avoidance. 10, 11, 12, like that. So let us say so what did you understand from this? Whenever we detect the congestion, there are 2 ways you detect it. either by using the timeout or by using 3 duplicate acknowledgements. If we detect it using the timeout, then the new threshold is going to be half of the current congestion window, and then the algorithm enters slow start phase. In case if we detect the congestion using 3 duplicate acknowledgements, then the new threshold will be half of the current window size, and then the algorithm enters congestion avoidance phase. It is important. So why congestion avoidance phase is, 3 duplicate acknowledgements indicate that there is mild congestion, which means there is no congestion yet. There is a chance that there could be congestion. That is why you are trying to avoid it in the congestion avoidance phase. And here why slow start is, already congestion has occurred, therefore you slow down. That is why it is slow start phase, right? Now again at this point, let us say there is a timeout. Then what happens if there is a timeout? New threshold will become half of the current window size, which means threshold will be 6, and again you should enter into the slow start phase. What is slow start phase? 1. You should start with 1. So in some algorithms will start with 2. They are going to clearly specify in the exam, either it is 1 MSS or 2 MSS, right? 1, 2, 4, next one is 8, but threshold is 6. Therefore you cannot go till 8, you can jump till 6 only. After jumping till 6, you had again start with 7, 8. Now let us say at this point there is 3 duplicate acknowledgements. Then what happens? If there is 3 duplicate acknowledgements, again the same thing. New threshold will be half of the current window, which is 4, and the algorithm will enter the slow start phase, which means 4, 5, 6. Sorry, algorithm will enter not the slow start phase, congestion avoidance phase. Avoidance means linear growth. 4, 5, 6, 7, 8, so on until it reaches how much? 64. After it reaches 64, it is going to go there. It is going to be there, right? So understood this? That is how we are going to do this. So this ICMP we are not going to take care of it. This is just for the sake of your explanation I told you, but then it is not considered in any algorithms. You can think of it as 2 ways. Congestion is detected either by timeout or 3 duplicate acknowledgements. For your understanding, let's extend this question, this example for some bit. Now let us say the congestion window has reached 64 and we are sending 64, the maximum window, the full window all the times. Now at this point, if a timeout occurs, what happens? Then the new threshold will be 32, half of it, and again we start from slow start, which means from 1 we start. 1, 2, 4, 8, 16, 32, right? Let us say after sending 32 there is 3 duplicate acknowledgement. 3 duplicate acknowledgement means 1 packet is lost and after that 3 are received. Then what happens after this 32? We are going to have the new threshold as 16, half of it, and again we are going to start with linear growth, which means 32, 33, okay. Congestion avoidance is starting with 16, 16, 17. After sending 17, let us say there is a timeout. Then what will be new threshold? New threshold will be 17 by 2. So what is 17 by 2? It is 8. So 8, and I have to start with again slow start phase, right? So what is slow start phase? 1. 17 by 2 is actually 8.5, but you should always take the base. So that is why I am taking floor. Floor means 8, right? Then we will again start from this slow start, 1, 2, 4, and we go till 8 only, and then we grow linearly, 9, 10, 11, so on, right? So this is how this algorithm works. Maybe one example is I have taken lots of examples in this one example. This is good enough to explain all the concepts of how the congestion algorithm, congestion control works. Okay, this is how TCP congestion mechanism is responsible for taking care of the traffic. So because of TCP only we are very safe. But the problem is not every host is going to follow these rules. There have been many cases where we found out that even though you are supposed to send the packet slowly, some people will be so careless that they try to send all the data at once. Therefore, it is the responsibility of your ISP to detect such activities. If someone is not following these rules, if they are sending the data directly onto the link, then there could be congestion. Therefore, your ISP should detect it. But the problem is these days even ISPs are also notorious, and they want to have let us say better bandwidth or the best bandwidth to their customers, then they are allowing their customers to drop the send the packets like this. Then IETF will take care of such an ISP. So as a host, your operating system is already configured or coded in such a way that it follows these rules. In case if you tamper that, and if you try to hack the code, and if you try to send the data at a higher rate, your ISP is going to catch you and ask you to slow down. In case if you don't slow down, they are going to cut your internet connection. Okay, I mean they are going to bar you. And in case if ISP is also notorious, and if it is allowing it, then IETF will take care of that ISP. Okay, so anyway, everyone is supposed to follow these rules, then the game will be fair, right? But then there are some applications which doesn't follow these rules, and such applications are multimedia applications, but then they should not grow very rapidly. So they can send up to some limit, but then after that limit, if they are sending it, then also ISP will block it or IETF will block it. Okay, so because of this congestion control algorithm, we are safe in the internet as of now. This is a very important algorithm.